Okay, let's talk about orbits. So something's orbiting if it's in a curved path around an object due to the force of gravity from that object. So we normally think of like the moon orbiting the Earth, stuff like that. But how do things actually stay in orbit? So the analogy I like to use is a throwing contest. So say so here's my buddy throwing the ball, gets this far, and then it hits the ground. Then I say, okay, I'll do the same thing, but I'm just going to stand on the hill. So even if I throw with the same strength, it'll go further. Just because the Earth kind of curved out. Right, so the Earth curved out from underneath the ball. And that whole time the ball was falling towards the ground, but the ground just happened not to be there until it got to here. If we extend this, you can imagine that I could throw a ball fast enough that as it's falling towards the Earth is curving out from under it, so it never actually hits the ground. And that's what it means to be in orbit. So I can draw the velocity of an object that's orbiting. And I'll show you an arrow, this is its velocity. And I'll show you another arrow, which is acceleration due to gravity pulling it in. But since it's perpendicular, all it does is it changes the direction of its velocity. So this whole time, this object's going to be going the same speed, and it's going to have its direction changed. Because at each moment, the force of gravity is kind of yanking it in, and it's just kind of turning its direction. And you can see that it's just yanking it just enough, right? And it's always being yanked towards the center that it never actually hits the ground. Okay, so if the object is not going fast enough, what will happen is it'll eventually hit the ground. And you can see that because the Earth is curved, it stays up longer than it normally would if it were flat. But in this example, the object falls faster than the Earth curves. If I were to draw that again, a little prettier, without the arrows, you could get something that would go like this, and then crash. It's again because this distance, right, this distance between the Earth and the object's actually decreasing because the object is falling a little bit faster than the Earth can actually curve out from under it. So it's kind of slowly catching up. The other thing that can happen is, of course, the thing starts moving too fast. In this situation, you might have a really large velocity, but the acceleration is going to be the same. And if it's fast enough, the object's distance will, or the distance between the Earth and the object will increase as time goes on. right?